All right, today is the day. We're going to turn this solar shed that you see here, and have you seen many times before. Got the shed prepped, got all the solar products, and a brand new, eco-worthy IC 3000 watt, 12 volt, 120 volt, 60 megahertz, 100 amp charger, ready to go. We're going to install this in the solar shed, and then we're going to test it all out. Get ready, it's going to be a fun ride, and the solar shed is going off grid. So today we're doing things a little differently. It is hot, and I mean it's hot here in Florida today. So I've got the canopy above me, the solar shed's way in the background over there, and I'm just kind of going to start unpacking things and work here on the benches as much as possible, and then we'll transport it over there. So we're going to start with the unopening, and I want to thank EcoWorthy for sending me this new inverter. This should provide us enough power to run everything we need in the solar shed. It's also designed for RVs and even has a lot of the important pieces that you're going to need to go with it. This is one of the first pieces that I thought was really, really nice. Now, as you can see here, these wires, that's a charging wire, but these wires are not small. They did a really nice job of sending good quality battery cables. These are not underrated. The lugs are nice sized. The battery cables are nice. The finishings are nice. They did a really, really good job on these. And so that's actually really nice. They've also got some protective muffins and stuff for everything. So that's great. Then we have the actual inverter. Now, let's talk a little bit about the inverter. Get it out of the box here. It's a pretty simple packaging. There isn't anything super fancy about it, but you can see here, it's, I don't know, 25, 26 pounds. But it's not too heavy. But it's 3,000 watts, 6,000 watts of surge, and 12 volt DC, which was important because I want to build a 12 volt system for the solar shed this time. So it operates between battery voltage rating between 10.5 volts and 16.5. So it should handle lithium batteries perfectly. Shouldn't have any problems there. 60 hertz, 120 volt AC output. Nice input frequency is input frequency. So this is the nice thing about this is it's an RV rated, mobile rated certifications here in the US and in Canada. And I will put the specs from that, run it down the screen here, out of the manual. I remember reading it, but I don't have it with me. But they include the cable for charging. So the nice thing is you can plug this into an RV. And when you pull into an RV park, your system switches over to run off of the grid. And when you pull out, it switches back. Now it has a 30 millisecond switch rate between being on the battery and being on the grid. So it's a little slow there. It could be a little bit faster had they got it down to 10 milliseconds. You probably wouldn't notice it on any devices. So there might be some devices, alarm clocks or things like that that are, that reset and start over. For the most part, most items will handle 30 milliseconds okay, but you're not going to have that on every device. You're going to find that some of them are going to reset a little bit. You might see a little bit of flickering in LED lights if your LED lights aren't already running off a 12 volt directly, which in most RVs they would be. But this is marine grade, mobile grade certified. So that's the nice thing. It's not too overly heavy, but it is a 12 volt, 3,000 watt, 100 amp charger. Now, keep in mind, it's only AC charging. It does not have PV charging in it. So when we get to the point where we're doing the solar setup itself, we will still need to hook up the Victron charger to take care of that part of it to hook the PV to. but that's okay. It's still a great choice for RVs because it allows you to get a marine grade charger that provides all of the bad bypass information and switches you need to run your 30 amp RV off of. And then it provides enough power that when you're off grid, you won't even know you're off grid. So it's fantastic from that perspective. Now, how it operates, that we yet to know, but we will find out. We'll do some testing on this thing and understand how it works. So going back to the specs here, we are, it operates basically in the 10.5 to 16.5 range. It has DC output range, gel flooded, AGM, lithium battery, pure sine wave, and it is pure sine wave, which is nice because then you don't have to worry about dirty power or anything like that. So it seems to be pretty simple. Now let's talk about the connections here on the bottom. I just need to push this camera down just a little bit more so you can see it a little bit more clearly here. So as you can see here, one of the nicest features I like about it is it comes with a built-in outlet here. So if your RV or whatnot is just plugged in, you can plug it into this 20 amp AV outlet. Now with 20 amps, you're not going to be able to pull the full 3,000 watts. So don't be mistaken that you can just plug your RV in here and get everything out of it. You will need to go with the input from the AC input from here. So let's find a screwdriver and let's take these covers off so that we can see how these things hook up. I'm just going to grab a couple of screwdrivers here. All right. And like I said, I apologize for the ad hocness of this today, but it being so hot outside, I just wasn't going to work out there in that sun while we did all this. There was no reason for it. All right, so we just take this off, and I got to be careful not to drop anything in this deck here, or it just disappears. Okay, so that's not too simple. That's not too bad. Let me see if I can get you a good view of that. So basically, what this is, you can see from it, is the wires run in here. It's got neutral and a line, neutral and a line. This side over here is for your AC input, and these two over here are for your AC output. So we'll be able to run an AC output. Now I've got a really cool box that we're going to use for that so that we can show the distribution box. Now in most cases you'd probably run that directly to using 8-aught wire. You could probably run that directly to your RV fuse box and have the plug run in here. So the electrical diagram that which you would want for this is that the grid plug comes in from where the RV is currently connected, comes in and goes into the AC input, connects here, and then the AC output goes from here to the breaker box in your RV. And then this acts like a switch between the two. Whether you're off grid, this turns on, and when you're on grid, you can either have yourself use the batteries and use this as a backup, or you can put it in backup mode where it charges the batteries, and then when the power goes out, it kicks in and you have full power there. So you can operate it both ways. Now, there are a couple of items here that I was a little disappointed with the CAN bus here. I thought this was going to hook up to some things, but this seems to be just a plug for their batteries. I'm going to get a little bit more details on it and worry about that. There's a programming port here for the USB, and there's a couple of things for the remote and remote screen and stuff. These here are for the connections to the battery terminals. And as you can see, these wires being beefy enough to actually support these properly, which is nice. Thank you for providing good enough sized wires to where we feel comfortable running it. These are definitely able to support the wattage that it would come through there. And as you can see, that's pretty decently done there. This will run directly down to the batteries. And there we go. Let's see if I can get that loosened. But either way, as you can see, it's quite a simple device. It only has a couple of connections, one to the battery, one to the AC in for AC charging or bypass mode, one for AC out to run your AC devices, or you can simply just run it through the wall plug here. Now, if you run it through the wall plug, this is a 20 amp plug. You will not get the full 3,000 watts out of a 20 amp plug. AC 120 at 20 amps is only 2,400 watts. So you wouldn't be able to pull everything out of this, and you probably wouldn't want to anyway. But, and you've also got a reset button there. The screen here, we'll go over that when we get it hooked up, but this is a good little device. And grounding here, they specify in the manual that on grounding on this one, that you need to pay, that this needs to be grounded to in your RV system, it should be grounded to the frame of the automobile. That's true with the boat. There is a common grounding bus bar that it goes to. And so that's where you would ground it on a boat and in the RV there. Now, one of the downsides I see here is this, it doesn't have any IP 65 ratings or anything like that. So it is strictly rated for inside use. That makes it a little bit difficult to use in some RV situations and in some, especially in some boating situations. But it certainly will work. You just have to be more careful with where you put it and how you put it there. All right. And these little booties cover those connections up so that those wires go through there nice and clean, and you don't have to worry about accidentally getting something on. Oh, it's got little clips here at the base of them too to hold them on, which is kind of nice. All right, that way you don't have to worry about those just pulling off. So that is the basics of the unit that we're hooking up for the inverter and the inverter charger to demonstrate how this would be used in an RV system. But we are going to convert the solar shed because it is also perfect for a solar shed. The only downside that I have seen with it as far as a solar shed or an RV or anything of that nature is that its heat rating is extremely low. It only can withstand up to 105 degrees, and the solar shed is not going to be happy with that. So we will have to hook this up in some kind of way where we can get a fan on it or something along those natures to be able to manage that heat. We may even see what it can take and see if how accurate that rating is and what it does when it overheats. I hear there's just a sensor in it that shuts off, and if that's the case and it just shuts off and then comes back on, then it wouldn't be the end of the world. If it burns out, that would be where we run into the real problem. So we'll save that testing for the very end. All right, let's take a look at some of the changes we're making here. See if we can get you a view of them. There we go. That should be high enough to see everything, I think. So we're not trying to get fancy here. We just want to do the basics. I'm thinking we place the inverter here and there we go, charge controller up here. The breaker for the charge controller to go in there. The breaker for the PV right about here. And I'm just going to button some of this down real quick. Put one in there. Give me my bit back. One in there. Then let's take this one and tighten it down before we put the PV in place because we can't move it afterwards. One there. One there. That puts this in a nice tight place. Then we can turn this to where it's straight up and down like it should be. Put it down. All right, now as you know, this is a 12-volt system, meaning this MPPT is only 20 amps. So it will charge very slowly because it's only going to charge at 240 watts. And that's okay. That's all we'll need because we're only going to be running 100 amp hour battery, which meaning the whole system is limited to 100 amps, which is 1200 watts pull out of this. So we are going to be a little bit limited by the size of what we can pull from this in this demonstration, but it will give you the idea of how everything would work. So let's, I think this looks good right about here. I want to put it over as far as I can get it. So I'm going to go ahead and put it in place also. I'm only putting 2 screws in each of these because I'm not going to be moving this around. It's just a temporary workspace to get everything set up. Okay, now the positive, we want to go through a breaker to ensure that we don't have any problems on the positive side. So here's what I'm going to do. We're going to take the positive, and I want to take the positive wire from here and just use it as a gauge of where this should go. We'll come back and tighten these all with to spec, but I just want to get it to where I know where everything needs to be. So what we'll do is this is a 120 amp fuse. I am going to put the fuse between these washers also. So what I want to do is make sure that this is in that washer also. There we go, like that. That's what I want. So that these can be smushed between there, making the connection between the cable and the fuse the most important thing. This is not a bus bar, so I don't need it to connect good to the bus bar. I need it to connect good to the other item in it. And in this case, it's going to be the other wire on the other side. So I want to put those between these like that. And we'll put that across there like this. Now, what I think I'm going to do is zip tie these down to where they cannot move and that we don't have any issue with this wire at all. So let me get some zip ties and let's take care of that. All right, so in order to do this, I want to try to keep this fairly simple. So I'm thinking I'm just going to take 3 of these like this. And I just don't want anything bumping them and knocking them around or anything like that. Let's get this where it's just the right spot there. And then we will tie those down so that it can't move regardless of what tension comes up. Like that. And then we're going to snip these off, pull them good and tight, snip them off so that cable is held. in place nice and neat. Now this will then need to be tied, buttoned down underneath this fuse, and I probably should have done this before. So what we'll do is we'll take this off, figure out exactly where it needs to be. We'll just move this off to the side to hold those fuses in place. Unlike these big heads, I like these big flaring heads for things like this because they really grab a hold of it, but occasionally you need the small ones like this. So we will switch that since those allow those to countersink in. And that allows enough movement to get that on there. Drop this here. I'm going to go ahead and insert this. And that will make the best connection here between these two being pressed together, because the bolt is nothing more than a space filler. Some current may flow through it, but the majority of it should flow through from this conductor to this conductor on the fuse, and we will test that with temperature sensitive. These fuse blocks, although they're really reasonably priced, I would not use them for full capacity all the time. I would go with a better brand, maybe, and I'll include a link down under better items or enhanced items down below for a more expensive marine grade fuse that you could use here, as opposed to this cheapo. This cheapo is great for doing demos like this, but it is not ideal for long-term use. Okay, now we've got that on there. We can hook the other battery cable to it, which will run to the actual battery themselves. Let's just take this off. And this is a nice wire that came with the inverter. It's 1/0. It's good and beefy, and it's got a good long lead on it that'll take us over to the battery. I think I need to zip tie this on also, just to relieve any of that extra stress there. Keep that from causing any trouble. And let's make that go the same way as the other ones. We'll put that on here. And we'll take this. Okay. Now we want to clean that up also. We'll move these screws out of the way. Get to the wire clippers. Cut that. And since that lead runs off the table into another place, I think I'm going to double it up just to make sure we don't have a wire pull loose and cause us some serious problems. With this being movable, you got to take extra precautions when you're doing things like this. Otherwise, you end up with really bad things happening. All right. Now, that should keep it from causing any trouble. We can tighten those down with a torque wrench. I missed a place for the lock washer here. I'm not sure if it'll make any difference. It's not in the mechanical hold, but I don't want to leave it off. All right. That's good. That's good. That's good. Now let's work on the black. The black is much easier. I'm going to go straight to the battery with this one. So I'm thinking we come down and around the same way, just like this. And then that will allow those extra length of that cable will allow it to stretch to the far side of the battery, as long as the battery is on this side. The positive is on this side, the negative is on this side, and I stick the battery right behind these. So I'm thinking of taking this and shifting it just like this into the RV, and these will sit right there on top of it. So let's put this here. And we already forgot something important. I want to put that on there. I'm going to have to go back and redo the other side. So now we want to do the same thing here. I'm going to tilt that down just a little bit and this one down a little bit, and make sure that this can get up there and cover that without any issue. It looks like it'll be okay. And then we're going to zip tie this out a tiny bit out, so that again we have that tension release and don't have to worry about the problem of it moving around on us. That's not how I want to do that. Let's put those screws on the same side there. I'll just put that right there. Bring this out just a little further. Since that one's mounted at the top here, I want to give it a little extra leeway there. And I need a few screws. See if I have any left. All right, so let's start by putting this one in. This cable's a bit stiffer than the one that I used to go to the fuse. A lot better quality cable. But it is not near as bendable, not near as flexible as the other one. So I'm going to just curve that all the way around that corner like that, and then button it down. I don't think it'll have a problem with it moving, so that's actually the solution here, is to prevent it from moving, and it doesn't have any movement in it whatsoever. These were a lot more flexible and move a lot. So, and then I think we'll do the same over here. We'll do one this way, and one this way. Right in the same neighborhood with those screws. And we'll double up on it again, just to keep the wire, when it comes off the table, from not having any stress and having a backup plan to it doing it. The wind caught that one, sorry. Now we will snip these off. Completing the wiring around those, short of not having all of those tensioned or torqued yet. The only thing I have to do still is put this on over here where I forgot it. Inevitably, you're going to forget something. And it's going to be something that haunts you forever. Just stop, take the time, and go back and fix it now. Otherwise, and it may end up being super easy like this to fix, and it may not be super easy to fix, but either way, you should resolve it quickly. That way you can move on. I had a friend once when I lost something, and he basically said, just go buy a nicer one and you'll forget that you ever had the bad one, the cheaper one. Here's what we've got. We've got the wires connected, going around the corner. The PV's here. We don't have it connected to anything. We'll plug in the actual solar panels when we get to that point. This needs to go off to the battery also. So we need to create some wires for this. We need to handle this aspect of it. This is going to have the input and the output. So the input is pretty easy. We're going to hook this plug up for the input. And I think what I'm going to do is hook up the output first. So let me get that and let's take a look at that. All right, so here's what we want to hook up for the power station. And I picked up one of these. There were some reviews done by Will out on the internet where there was some problems with these. This is one that has been corrected, and I'll show you what he saw as the problem and what they have since corrected. Originally, if you look inside here, you'll see that there is a negative that runs to each of these plugs and a blue wire, which is the positive that runs to each of these plugs. And they had daisy chained these together like they did ground in here, which isn't safe because that would mean that it would support the load of all 4 of the plugs. And I think they had daisy chained 2 together. Either way, this one has been fixed, so it's not a big problem. So all we need to do at this point is find a nice place to mount this on here, and then we will route the power into it. And I'm just going to move these tools over here and these screws into that corner. Get this screwdriver out of the way. And so we know this is going to run the power. So what we can do is we can run it up into there. And just loosen that up, push that up in there. I don't like the way that fits. And let me show you what I mean. So this is a pre-cut piece, and I just don't think they included enough room for this. So this is a pre-cut wire, and the gland is right here. And the wire, if I pull this back where the wires fit into the connectors, then so neutral and line. Let's just see if we can get the neutral and the line in. You know, I don't know if those are in good. Let's just tighten one down. Let's see if it grabs hold of it. It doesn't look like it's far enough in there. It's not. All right, so let's try this again. Let's loosen these up. It's hard to tell from these glands what these outlets in here look like. No, there they go. Now they popped in. Let me show you. Those slid all the way in that time. You can see here. Let's see if I can get that turned enough for you. You can see here they slid all the way in. That's much better. That tightened down for sure. Gripped a hold of that line really well. Yeah. Now, weirdly enough, let me make sure those are in there really good. I'm going to tighten this, go ahead and tighten this gland down so that that's not moving anymore on it. And we've got the same issue here with this the neutral. And I'm not sure exactly what they anticipate you doing with this neutral. Let me just investigate a little bit and see if I can figure that out, because that grounding screw is right there, but this wire is not obviously not made for that grounding screw. And there's one on each side, so I know that's the right spot. And they have the grounding symbol on them. But that would have been nice if that had been, you know, a grounding clamp like over here on the other side. Just a small one of these would have helped quite a bit. Because then that wire could just go in there, we tighten it down, and wire could have just gone in there, we would tighten it down, and that would have solved everything. But instead, we have this screw here and just a loose wire. So we're going to try maybe putting a little connector cap on it, and I can back it up like this, put it up in there, and see if I can get that on there. Give me just a minute, see if I can hunt down a cap for that. All right, so here's what I found. I found a couple of blue labeled things. I only need one for this side, but I gotta see if I can get it actually in there to get it crimped or not. That's going to be where the remaining issue is. If not, I gotta loosen this. Oh, look at that. That just twists right out where I can get to it. That's good. Slide that back in there. Push that out as far as I can. See if I can get this to well, crimped on, but it didn't crimp on. All right, let's try this again. Let's try it this time without the blue connector, even if we have to do some melting. Oh yeah, that's not going to fit in there. That's the problem. Okay, let's try something else then. All right, so we have the yellow one. It has a bigger hole. Oh yeah, that's definitely the one. Okay. And we'll just turn this way. I'm going to need to loosen this all up, I think, to get enough on it. There we go. I crimped that 3 times across that thing pretty well. Let me show you what I mean. So you can see there, crimped 3 times across there. And I should have done that before I put those on. So now it's just a matter of pulling it underneath here and getting it onto that screw. So let's get the all right, so let's get the screw, pull it out. And then I'm going to, I think I'm just going to, I don't want to take a chance on, this seems to be the road of least resistance here, which would have made everything else a lot easier if I had just done it in the first place. Okay, let's see if I can get this. that out just a little bit and twist it around like that. And these two need to go back in, but this needs to be under them. So let me just twist that under them like this. It's a very tight fit. I wish they had made this with a little bit more room. Just a little bit more depth here would have been all the difference in the world. This would make it very difficult for someone who's, especially someone who's new to it and gets in a hurry, doesn't realize you got to tinker and fiddle with all this little things like this. And okay, there's the ground. They get to the point where they just skip things like a grounding screw, and that's never a good thing. So now I'm tightening this back up on the back side here to hold this wire in place. Okay, now we're good and tight there, and that's good and tight. All right, now let's get some wire for wiring up this device. And just in case you couldn't see it earlier, this was where we had the problems when the original investigations were done on these. These wires here were daisy chained to connect either the black or the blue, and I don't remember which one, but they daisy chained them like they did the green here. Now green, obviously, a short should be boom and blow the whole thing and pop the breaker, and that would be the end of it. So that wouldn't be a big deal. But when you do that with the power and it's got a constant pull, that meant that that wire needed to support the voltage of all four of the outlets as opposed to just one. That was its original problem. And these wires seem to be large enough to support. So now we're going to take this box, secure it down. That seems to be good. 2 is enough. Then we're going to take a piece of 10 gauge wire, strip off both ends. And I do want to take this, put it up in here. Same thing's true here. This is damned frustrating that these glands are so close to the they're so close that the only real way to do this is to take the whole thing apart or take the glands off. The glands are supposed to make this easier, not more difficult. And there just simply isn't enough room in here to do this. So what you end up having to do is take all of this apart and this gland wasn't really made to be taken apart either. It's kind of rough and toughing it. All right, then we put it back through here and drop this over it. Now, in order to do this, I gotta bend this and make the shape of what I need. for that ground wire. Got to try to get all of these just perfectly lined up so I can just push it on there, because there just is no other way to do it. Just want to make sure both of those go completely in. And then I tighten down on them good. And then I can put the ground on, because the ground is going to pull it in an odd direction and pull them out if I haven't gotten them tight yet. And there simply is no room in here to work. Just very frustrating. I don't think they took the connections. I hate to say it, I just don't think the grounding and the wiring connections here were taken seriously enough to just how simple this needs to be for people to use it. What is this? I mean, I know what it's supposed to be. Okay. Let's do the same thing we did before. Let's just take a couple of zip ties, secure these down so we don't have to worry about things moving around on us. Here. Here. Sometimes you gotta go figure out where your drill bits get stuck. Okay. So we have 3 wires in here. Neutral. Trim off just a little extra of that. Get that to fit all the way in. Line. Now we're just going to double check all of the connections before we move forward. All right. All right. Everything is off. Everything is connected there. Let's take, and let's put the cover back on. Let me just kind of show you what everything looks like once it's done. Ground, common, neutral, or neutral line, ground, neutral line. Lines in the middle, neutrals on the outside. Nice. You saw everything in there. Put this cover back on. The only thing I found that was really frustrating in here is this compartment is simply not big enough. It needs to be wider where you can get in there and you can actually get things connected correctly. Otherwise, if you're working on this and you're frustrated, don't take shortcuts, because those grounding wires and those wires there can cause you a lot of trouble if you don't get them right. Okay. Everything there is good. Now we just need to test some connections. All right, so we're going to basically set the torque wrench here to a little over 11 foot-pounds. I'm going to say 11.2. And then I'm going to show you exactly how you basically, you just twist this until it beeps at you. And it's pretty obvious when it does it that you're done. So you'll hear it as we tighten this up. So here I'm going to take this torque wrench here. I'm going to back this camera up a little bit so you get a good view of it. And we just start to tighten. I'm going to hold this cable straight so that it's sticking straight out so that that protective cup can go on there. You hear it starting to beep. I'll move this microphone down there so you can hear it. That means that it's tight. And I'm going to just twist it a little bit and do it one more time. All right, that side's done. Then we're going to flip over to the other side. And you want to make sure that you turn all the power off when you do this, because you can see how easily you can slip when you're on that. And you don't want to slip and short something out. And this one is also tight. We move this cap up and on there. And that's all there is to the torquing. You just need to make sure you torque every screw, every nut, depending on the torque wrench you want and the torque wrench you use. That'll ensure that everything works the way it's supposed to and that you don't have any loose connections. All right. This is the system that we are going to be using for the solar shed. And it is, other than the solar panels being hooked up here, which won't get done until we get over to the solar shed itself, everything else is all hooked up and ready to go. The inverter is here. The AC has breakers. The DC has fuses. The PV is over on this side here, and we have hooked up a Victron 100/20, the 20 amps of output to our 12-volt battery, so it'll be 240 watts of solar panel. We have a shut-off going to the batteries for charging, and we have a shut-off coming in from the PV, which we will do. Next, we will move this over to the solar shed, and we plan on mounting it right in this area along this wall. And as you can see, the PV is here. Now we have much more PV coming in here than is needed. This is the full solar shed. So we will reroute one of these connections, one of these 4 that come in from the top of the solar shed, to our system here, and we will leave the rest going over to the RV until we determine what we want to do next. And as we get into larger systems, we may want to move more and more of this solar into them. But we're starting with this 12-volt system, and we will put that right here. And on the next video, you will see me moving it over there, and we will take this solar system to the next level and start testing it. The last thing that we're going to do today is I'm going to turn this solar system on, and then we are going to charge the batteries. All right, we're going to do a quick power on sequence before we take this to the solar shed to check everything and make sure it works. So in order to do that, I've got the solar shed, as you can see, plugged in here. This is running everything over to the solar shed right now. So I just want to kind of test everything out before we get there. So I'm going to shut off all of this power here. I've turned on the DC batteries. So there is power running to the DC terminals here. And we would want to check that. So what we'll do is we'll pull the meter up here and we will connect it, turn it on DC voltage. We'll set this where you can see it clearly. And we're going to set this to DC voltage. And then we're going to take these terminals and we're going to push one in here in the, I'm going to have to pull these off a little bit in order to get to it. There we go. I'm going to push one in here in the negative. And I'm going to push one in here on the positive. And as you can see, we're at 13.1, which I'll pull up the state of charge on those right now, and you can see they're about 30%. So here's what we're going to do. We're going to power this thing on now that we know it's at a safe voltage and the polarity is correct. Now, keep in mind, you should always check polarity, and let me show you exactly what I mean by that. I want to make sure you can see it. There we go. So you can see the voltage here, and when I put this on the negative here and the positive here, we show 13 volts. Now, if I have these reversed, you're going to notice right in this area here that a negative symbol is going to show up. And you can see there, that's negative 13 volts, and that means that the polarity is backwards. Now, I have the cables backwards, so this would mean that the polarity is right. And you always want to check polarity on batteries to make sure that you have it correct and accurate. Now, we're going to put these safety caps back on here to protect keep any mistakes from happening. We're going to pull this back again, and we're going to start on the power on sequence. So we push the power on button here and hold it, and you can see it's flipped on. I'm going to try to zoom in here on the screen so that we can get an idea of what's going on. All right, that's good. It shows 13 volts, which is what we had. And we see AC output, and we see a status of green, and we do have AC going out from the batteries. So all of this is good. Now I've got this set to a 25 amp charge. So what I'm going to do is I'm going to take the charge cord, which if you remember when we hooked it up, was just a simple wall outlet that we connected to it. And I'm going to plug it in. And we should see this switch into bypass mode, which it did. And it's going to go in here in a second. We'll hear it click. There goes the click. And AC in. And the battery has started charging. It's as simple as that when you have this set in bypass mode, that if you were using this in an RV, then you could pull into your RV park, plug this into the grid power, and this would switch to bypass mode and in turn charge your batteries. Now, you can set it as, so it'll act as an UPS, and when the power goes out, it'll do it. Now, you'll notice over here that we've also got power to, it's kind of hard to read. Oh, here we go. Just have never taken off the protective coating, so you can't see it very clearly. Let me just do that while we're here. So you can see here, we have power to this, and you can see that's on. So what we're going to do is we're going to turn on these circuits, and that should power it up. Now, that should have powered up the solar shed, but before we go over to the solar shed, I want to throw a little tester on one of these and just check the polarity and check everything to make sure that we have a good solid connection. Not only that we have power, but we have the correct wiring for the hot, the neutral, and the ground. And we don't have any wiring issues there. And this should be true with all of these plugs, and it looks like it is. And then we're going to go over to the solar shed. I want to switch this one from there to here. And we're going to check that one, and it's good. So now I'm going to walk over to the solar shed real quick, because we have that power coming in through that extension cord, which you can see here. We're going to come over here to the solar shed. We're going to take a look at the outlets that are in here. I'm going to flip the lights on, and the lights come on, which is a good sign. Now what I want to do is I want to know if the outlets here are all wired correctly also. And if I plug that in, as you can see, we got a good wiring here also. So that means everything is properly grounded. Everything has the polarity correct. And we are all set up and ready to rock and roll. So now in the next video, teaser, in the next video, I will be showing you how we hook the solar system up here, and we'll connect some panels to it. And then in the third video, we will connect all of the panels, reconnect all of the panels to the solar shed and get everything rocking and rolling permanently. Right now, all the solar panels are sitting out like this. And so we will mount them to the solar shed, and I will show you exactly how that is done and what I do to make that happen. And that will in turn allow us to, you can see my creative engineering here where I needed this to be out from the wall a little bit to get more sun. So I propped it up just a little bit. But this is the next 2 videos. So we will see you on the next one. Thanks for watching, and we'll see you there. Welcome back to the Solar Shed series. Today we're going to break down the solar system, the switch set-off switches, the AC input and outputs, the charger, the inverter, and we're going to go over the entire system, test a bunch of the breakers, test a bunch of the wires, do an upgrade on the system already. My name is Matt. Welcome to the channel. There's always a parts list that you can scan on the screen or right in the links below. All right, so today is the day when we start to move this into the solar shed. Seems to fit pretty well right there. What do you think? Let's just take this camera back a little bit further. See what you think. So now we have all of the cables that come off of our solar pre-assembled solar system from yesterday. So we will pull all these over, and then we need the leads that connect the parallel leads. Unfortunately, all I have is these long leads. So we're going to use them. We'll make do. Maybe we'll zip tie them when we get done here. Set this off to the side here and see if we can come up with a way to make that work. Yeah, let's do that. So we set this one like this. Just make that wire a little longer that way. So that would be kind of what I'm thinking is something like this, where we have enough lead to connect them, but not so much that it's in the way all the time. And then I'll just twist this around for this side, and this one for that side. Maybe I can just get a zip tie or two and put it on these cables to keep them controlled. Ideally, you would make this as short as possible to prevent any voltage drop or anything else like that from happening. For our purposes today, this should work. And I hate, there we go. All right, so now we have the two leads for that side and the two leads from this side, and we can just slide those in together that way. All right, now what I'm thinking is batteries are like yin and yang. For every yin, you need a yang. So we're going to yin and yang everything as we put this together here. So the positive battery on this side and the positive connector on this side with the inverter pull on the bottom to get the most current directly. Little things like this make a difference. They can make a difference, let's just say that. So we basically put that there. All right, then the yang of this is the negative side to the negative side from the battery over here. And we take not that one, this one. And we need to back that up just a little bit. Here. So the paralleling side is the same. Then we have the charging side also. As you remember, we took the solar and we built a charging side. So what I want to do here is basically the same thing I did with the other one. I just want to take some of this excess wire, just kind of roll it up, maybe zip tie it down a little bit. Doesn't have to be gorgeous, but we'll zip tie this into a loop so it doesn't get out of control on us and just be spiraled out all over the place. All right, there we go. Now, the yang is, it discharges from one side and charges from the other, but each one is on a different side of the battery. So this should hopefully help keep it balanced to a certain extent. This time, I want to twist this around this way so that it doesn't get, when I slide it in there, it doesn't get caught up underneath there. All right. And then the parallel side over here, we'll do the same thing, but with the positive charger cable and the parallel cable running to the second battery. Now, we could have just as easily ran all this to a nice bus bar, and that would mean the positive to a bus bar, this positive to a bus bar, this battery to a bus bar, and this charging cable to a bus bar. So all four of those connect to a bus bar, and they would have all fed off of each other. All right, so we're going to torque these down to right specs and then slide it into there as carefully as possible. All right, so we're just going to quickly connect the torque wrench or the torque connector here, and then we're going to adjust it to 10.5 nanometers. I think it's 9 on this one. I'm going to do 9, and then I'll check the paperwork and make sure. So we have 9. This is a fairly simple process. Just make sure the cables stay right. There we go. All right. And then we're going to slip this underneath. We don't need that under there. And we don't need this. We're just going to slide this underneath now. Flip this over so those cables have enough room to move. Under here, out of the way. I don't like, that's the charging cable. We'll just leave that over there. I don't like this, the way this sticks out. So we may have to come back and redo this. But for now, let me show you what I've done. What I don't like is the way I came out here, and these come out into the aisle, into the way. Now this one, obviously I can move, no problem there. I can tuck it up underneath there. But these are so unflexible that I kind of ran them in the wrong. This is the problem with pre-building something that you slide in here. Your plans don't always work. They probably should have come off the other side, and then they would have been hidden. And that is not really much of an option because in this case, I have the fuse here. But either way, the solar system is here now, and it's in, and we can power it on. Everything has been torqued and checked. So here's what we're going to do. See if I can make sure you got a good view. All right. So here we are. We should be able to just see the light come on the charge controller. And it did. It blinked on for a minute with 12 volts. That should adjust it. We might even be able to see it with Bluetooth. But we got to turn the power on for that to work. So I got to take my phone, turn the power on, and then I'll be right back. All right, so here we are. We have the system set up now. Batteries are on. I want to turn this on so I can see this come on and make sure that I have the right power. You can see here it is blinking. At least I hope you can see that. There it goes. I don't know if you can see that or not. Let me see if I can shield that a little bit where you can see it. Hopefully you can see that. Either way, this is blinking, which tells me that 12 volts is there. I'm going to switch over to the Victron, and then I'll switch back. Here we are in the Victron app, and we're going to go over to the coffee trailer, which is the device that we're looking at, the MPPT 10/20 controller. After it loads, you'll notice that there's no input at this point, but we do need to set the battery voltage. And you'll notice here it's set to 24 volts, so we want to change this to 12 volts, and this is something you should check every time you set your system up. It will ask you to confirm it with a code like it does here, so that you can be sure. Charging the wrong voltage into a battery can be very detrimental to the battery, so please make sure you confirm it. Once this is changed, and we see that we are at 12 volts and 20 amps, then we can exit out of this, and we can go back to the rest of the setup. Now we have, this PV is still off. I don't have the PV hooked up yet. But we do have the main box here and the inverter. So let's see if we can turn them on. All right, so the short is I disconnected this line, found the negative that went with it, and then routed it into this with some extension cords because they weren't just quite long enough to make it there. Turned on the PV, turned on the charge, and as you can see, we are in float, or we are in absorption, and we'll give it a while and check, see how it goes. Other than that, I'm going to leave the light on in here just to give it a little bit of a fight for charging all the way. We'll let the test begin. All right, here on the screen we have the thermal sensor, and as you can see, it is running extremely hot. On the right-hand side, you'll notice I show you the batteries, and they are both pulling in excess of 800 watts as this thermal gun, as you can see there, is pumping out about 1800 watts or 16 to 1800 watts of power. You can see here the temperature at 180 is really just a bit excessive for the wires that are provided. We probably need to go with 4/0 if we want to go up this high, or if we want to even get anywhere near close to 3000 watts. So we're running about a half capacity right now, and that's all I'm really comfortable doing. So I did run this test for about 4 hours and drain the battery down from 100% down to around 25% or so. And then we let it run overnight. And this is what caused the shutdown overnight. And we learned that the re-enable did not come back on. But part of that, I think, was more configuration than anything on my part, as we'll go into the configuration of when the battery shutdown should be. If the battery shuts down instead of the inverter, then it's not going to come back on. But if the inverter shuts down and then the battery recovers with the Victron in the morning, that's when it would do. Now, I noticed that it did have a battery recovery the following morning. So we'll get into that. But either way, this is entirely too hot to continue to test this all the way up to 3000 watts with the provided cables. It is early enough in the day that I want to make a couple of changes. I was looking at the thermal readings and determined that really the problem is this cable right here. This cable is an old stereo cable that I had, and I didn't realize this is a 1/0 cable. And so what I've done is I've made a good piece of good marine grade 1/0 cable connector to replace this one here. So what I'm going to do is I'm going to take this cable off, and I'm going to rerun it and rehook up the breaker, move this over, and probably punch these through somewhere in this area right here so that those wires are hidden back there also. I'm going to try to take care of both of those at the same time. The next thing I want to do is I want to reroute this PV to where it goes back through the panel about down here also, and then it can go up behind the panel and connect over here like this. So this shouldn't be too difficult to get done, but I am going to have to shut everything down and pull these off in order to make it happen. So I'm going to start off by just cutting the batteries out, and then once I get the batteries shut off, I will come back and I will walk you through the changes I'm going to make. All right, be right back. Okay, I'm not sure exactly how I'm going to film this yet. I didn't think this through very well. So I'm going to put you over here and hope that I'm not too much in the way of you watching. So first, I might just slide that out. I've got all the batteries disconnected. So let me just see if we can just slide this panel out. I've got PV shut off, and I'm just going to disconnect PV over here so that those connections are not live at all. Batteries are all off. Inverter is off. Power is off. There's nothing connected to grid, and all the batteries are shut off. So let's start off by just changing a few things up here. And this is common when it happens when you work on a solar system. You got to learn to roll with the punches. Things change, and especially on safety issues like this one, you want to just go ahead and make the changes you need to make. So I'm going to cut these zip ties. There we go. That gets them out of there. Then I can use the screwdriver just to unravel. Just place the screws right here, because we're going to put all these screws back. But we're going to fix all of the problems that we ran into. The first problem is obviously the heat. That's the most concerning. We can't leave the heat problem and test it with any significant amount of power. And when I was building the video, when I was editing the video, I recognized that the problem wasn't the size of the wire, it was that actual wire that was the problem. So what I'll do is I'll just replace that wire. I use those sometimes in smaller systems with higher voltage because they're okay with the higher voltage, but at 12 volts, that is not going to work. So we're going to take all of this off, and we're just going to see if we can push through this pretty quickly here. Now the other thing I'm a little uncomfortable with is I don't like this fuse block. It has a tendency to get hot. This brand, the plastic isn't rated for hot enough to handle what they've claimed that it handles. So I haven't quite figured out what I'm going to do about that yet. I might order a Blue Seas version. I might figure out how to just want to put all the pieces back on here so that I don't lose any of them, because that would be like me. I get distracted and then I lose track of where everything is. You know, it is really hot out here today, so I'm a little worried about the camera getting hot. So let me see if I can find another place for it, because that spot was not going to work. Okay, that should work there. It's kind of in the way, but it's better to be in the way than overheat and not work at all. All right, so let's just start with this positive cable and get it off of here. I don't remember what size. Yeah, it was a smaller than this, I think. Probably better. Yeah, there we go. Let's just do it this way. Completely disconnected there. Okay, now let's just cut that one out completely. I should have known this wasn't going to work when I did it, but that is why you test systems. You never know where you have a weak connection, a bad lug, a bad cable, something along those lines. So you want to, obviously you want to think it through and build it to the right specs, but you also need to not be so arrogant that you don't test it when you're done. And that is exactly what I did, and always what I do when I put together a solar system is I put the thermal gun on it, run it up to some limits that I hope it can handle, and start doing some testing to see if I can get it to show any signs of problems. It can be very, it can save you a lot of trouble. Like it did in this case. Had I just ran this at 3,000 watts, it would have obviously caused problems with the wire, would have melted, and it would have been some very serious issues there. So you have to be very careful, especially on 12-volt systems when you're running anything over, anything over 100 amps. I would say you're going to want to be extra cautious about what you're doing, because things can go very wrong once you get up into those high amperages, which is why I always prefer, not always, why I usually prefer your higher voltage systems, because it eliminates a lot of that risk from the problem. Now, I did not have to remove this black wire. It was the original factory wire, which was handling the heat and the amperage just fine. It was high enough quality. The lugs seemed to be just fine from the review that I did on it. But what I do want to handle is, since I'm in here, I'm taking this all apart anyway for the positive, I wanted to handle where these wires came out into the aisle and down and around. There's no reason for them not to just go right through the wall here, and then I don't have to worry about them sticking out in the aisle. And I'll figure that out as we go. But first things first, this is the new wire. It is a high-grade marine wet dry 105 degrees Celsius dry wet wire. So this should perfectly, this is what I have in the solar system in the RV. I built if you'll notice here, I built the cable with the lugs facing the directions that I need them to face. This will help me not have to twist the wire once I get it in there and put any unnecessary tension on it. So what we'll do here is we'll put this back on here. Now on these wires, I did learn last time as I did this, is that booty doesn't go on very well unless this is straight out. So what I'm going to do is I'm going to put something behind that lug when I tighten it. And that way it holds it at that angle of straight out, so that when I tighten it, I'll check that with a torque wrench. Now, when I tighten it with the torque wrench, this should be able to slip right on and easily connect. Now, I can just put that zip tie a little further out so that that doesn't have any issues for me. And then we will move the fuse further over to accommodate the shortness of it. Now, I intentionally shortened it a little bit in order to give us the ability to put the cable through this and go into the back. That way we don't have it out in the aisle. So I'm going to put this fuse on here. Keep in mind, And I want to explain this. I don't know if I did this well the first time, but in this breaker here, I am sandwiching the fuse and the lug in between the washers. So this is lock washer, regular washer, fuse, lug, washer. The idea is to press those two items that the connection makes together, because the rest of this is just there to hold it together. It's not where the electricity should be flowing. It should be flowing from this wire to this fuse, and then on the other side exactly the same thing, through this wire or through the fuse onto the other end of this wire, which is here, and that way you have minimal resistance going through washers and lugs and nuts and bolts and all that. You want the connections to be as solid as possible to the two items that you're trying to connect, and not. All right, so now that I've put those on a little bit, I got to put some screws in them in order to get them to be in the right spot. So it looks like that right about there is going to be probably the right spot. And so what I'm going to do, I'm going to pull this one off, and I'm going to screw this one in. If I can get an extra hand here. There we go. All right. Now, I think I can just twist that one enough to get a screw in it, so I don't have to take it back off. But if I do, I do. It needed to be measured correctly, and then we'll. All right. Now we're back in business with the fuse. Let's put the fuse back on. Before we go too much further, I really want this to go through the wood here. So here's what I'm going to do. I'm going to get us a drill bit and see if we can drill a hole in this wood here. That one's a little tight. I'll go just a tiny bit bigger. 3/4. I need a 7/8. There we go. That should do it. And hopefully that'll get the lug too. Let's just see what the size that lug is. Yeah, that'll fit the lug too. So the lug will barely fit through. So I'm thinking right about here, and then I can bring that back up and twist this corner with it. It's stiff, but it's not impossible stiff. Now, the only risk I have here is I drill the hole and then I can't get the wire to turn the corner. So let's just make sure we can do that first. Let's take this and say if we were going to turn that corner like this, oh yeah, we can definitely do that. This wire certainly can make that turn. All right, so we're going to take it right about here. Wow, those bits just eat that wood right up. All right, so let's just make sure that hole is. Don't have any rough edges on it. Oh yeah, it's nice and smooth now. Okay, so now let's see if we can get this cable. I'm going to put it around there, out of the aisle, completely back here, and then come through this hole and turn and connect here. Like that. That looks a whole lot better. And I'm going to have to, but it's important that you put the fuse in the middle smash between the washers so that that connection doesn't go through any washers. You don't really know what a lot of these washers and stuff are made out of. And unless you have absolute confidence that you don't mind it going through some kind of washer, could be a zinc, could be iron, could be copper. Probably not, but it could be. All right. Now we take there we go. That looks fantastic. Okay, so that is the idea for the negative also. So I'm thinking what I'll do with the negative is basically the same thing. I wonder if I should just bring it from over here and just run it straight up, or if I should, yeah, you know what, that's exactly what I'm going to do. I'm going to just put the negative over here. Drill almost has enough power to do that easily. All right. Now let's take this negative cable now. Here's a trick with this negative cable and this positive cable in these batteries. Is they same thing's true here. I want to keep the angle of straight out so that the booty that I left off can easily connect. So then we'll put this booty back on here, and now we ought to be able to put these booties back on. Of course, we'll pull them off and torque them, but I want to get all right. So now this hole and this one now are much better, and we will deal with. All right, so the next piece is I want to fix these two from coming in. I don't know if you can see that well enough. Let me just turn this up a little bit. I got these two connected here. So what I want to do is I want to do the same with them. I want to bring them in from the back. So I'm going to switch to a smaller bit, and we're not going to switch to a smaller bit. We're going to just drill 2 holes here. Okay. Wow, that left a huge mess, didn't it? All right. Now, We ought to be able to pull these from the back, get rid of all this extra cable, just push it in from the back, get it out of the aisle, and plug it in. All right. Then this end we plug back in. And as you can see, now we have PV that still comes in from this daisy chained on here, because it eventually will get hooked back up to this, and we will connect all this back up. But it just goes behind here, comes out here and connects. Electrical just goes behind here for 12 volt positive and negative, and runs back to the batteries behind the wall there. This becomes much cleaner, short of this AC stuff that's two of them run outside the shed, and one of them runs to the other side of this shed. So, all right. Now I think we are ready to turn things back on. So what I'm going to do is I'm going to flip back over to the app, and I'll be right back. All right, here we are. We're back on. So let me just grab this stick here and let's see if I can walk through some of the turn-ons here. So we're going to turn the battery on first to the charger. I see the blue light starting to blink. That's good. And then we're going to turn the PV on to it, and it goes into charge mode, which it is. That's good. Then we're going to come over here and we're going to power on the inverter. And looks like it's come on. It's booting up. And there it goes. It's operating, and the lights are all on again. That's good. Okay. So now we have everything back the way it was, except we cleaned up all of that wire. And we got a heck of a mess here to vacuum and clean up. But the wiring is much cleaner now for these two battery cables. They run into the wall and disappear behind us, and we can go back there and clean that up. The PV runs into this wall and disappears behind it, and we can go clean that up. All of this is back on because the lights are on and everything's working. Generator's still working. PV is there. So I think that was successful and very well worth it. Now what I'll do is, once it's not 100 degrees out here tonight, after this charges all day, I'll come back out here. We'll hook that heat gun up and we'll run us another test, and we'll check these battery cables again. We didn't have any problem all the way to the battery from right about here at this breaker, this fuse. From this fuse on, it was okay. From this fuse this direction, using this old, and this is one of those things that you do when you first start and you don't realize it. I bought these copper clad aluminum wires. Now this will say copper on eBay or something, and it'll be very deceitful. And you get them in and they're not really quite what you were expecting them to be. These are aluminum wires, and aluminum wires ratings are much smaller than copper. Pure copper tinned marine grade wires like these here can handle 250 to 300 amps on this system. So this is much better, and that should be able to handle the 3,000 watts of this without overheating. The only remaining question we have is, can the plastic on this fuse box here handle the heat? Now, if this heat is still in excess of 150 degrees, which that's my own little goal there, that I will probably find a Blue Sea version of the A&L one so that I can trust that it's not going to melt on me. That's my biggest fear, is that the plastic on these has a tendency to melt because they get so hot. And most of that is probably because the fuse runs very hot on these, and the wire, if they're undersized, then they're going to run hot, and then that causes the fuse holder, which is just plastic, to melt, and then you end up with a real problem of things start to go south from there. So I want to double check that tonight. But other than that, we are back on. The solar shed is back in. Looks like it took us a grand total of about 30 minutes to upgrade everything. So now we'll let it run for the rest of the day charging, and then tonight we will see what happens with the test. Talk to you then. Let's see what happens when I shut the light off and it goes below power. That shut the power off. That's not what we wanted. Alright, so we turn the power back on, let it reboot. Alright, let's try another setting. Maybe that just can't be moved because one of these other settings is in its way. So let's try low battery warning, low battery recovery. So let's look at low battery recovery. It says the default is 12 volts. So 3 is set to 12 volts. We're going to put it at 12.5. And now it's 12.5. Okay. So 2, we want to set to 11.5. So push, hold. And then it starts blinking. We move it up to 11.5. Push and hold. And it tells you it accepted it. Now it's 11.5. So 1 is set to 10.5. And now we can move it up because now it doesn't have a conflict with the other setting. Alright. So now it will shut down at 11. Now, the recovery is by default 12 volts. I want to see how low I can make this recovery. If it's 11 volts for shut off, let's just see what we did here. 11 volts for disconnect, and recovery is 12.5. Let's just see if we can move that to 12. And we can. Okay. So that should take care of that. Now, the other thing we want to change is this here. In setting 5, we want this to stop working when it's don't have less than 15 watts. So we're going to come down here and go around to setting 5. And we're going to see that it should be set off. We're going to change this to 15 watts. And we're going to set. Okay, now that should be set to 15. Now, Let's see what happens when I shut the light off and it goes below power. Oh, look at that, it shut off. If I turn power back on, that becomes a question. Do I have anything I can actually turn the power back on with? Because the only things I have connected are run with switches. So, let's see. Maybe I can turn the flashlight on too. Nope. Alright, I'll be right back. Alright, here we are again with this heat gun. It's later on in the evening. Here's the new setup for the solar system. I cleaned these wires up a little bit. There's our fuse. Our new wires go into the inverter. Everything is running just like normal, but it's all nice and cleaned up now. It looks a whole lot better. So now we're going to take the thermal gun. I just turned this on. Let's see see what it's pulling here. 118 volts, 11.9 amps it looks like. We'll see what this one says. 1.4 kilowatts. So 1.4 kilowatts, 1,400 watts. All right, we're gonna turn some lights on, bring this up a little bit, 1.46. Let's go over here, see if we can get a few more. Turn this on, turn this on. All right, now we are at 1.53, so 1,530 watts. So I'm going to switch to the infrared and see if we can see what kind of temperature we got going on. All right, so here we go. Coming out of this heat gun, 266 degrees. All right, so now we're going to take this over here. We're going to take a look at, I probably should turn this way so we can see. Oh, that looks a whole lot better than it did yesterday. A whole lot better. So as you can see, this is a whole ton better. And we still have some heat at the fuse, but it's 143 degrees instead of 180 degrees. So let's just take a look at the rest of these wires here. That is much, much better. I'm going to turn this sideways like this. That looks terrific. I am going to just quickly come over here to the, I'm going to pull these boots down on these positive and negative cable here because I want to see the actual lugs themselves. So you can see there we're at 105 on the exposed one. That's the negative. And oh, actually that's the positive on the backside there. So I'm going to flip this around and see if I can just get the backside camera view. There we go. And it's 105 also, 106. This is fantastic. Much, much better. Much, much safer. And that wire is completely not even in the game here. It is running at 92 degrees, 923 degrees, something like that. That's just crazy. much better. I want to see if I can get that fuse out of the thing so it lights that one up. There we go, 127 there, right there at that joint where 156. Oh, that's the fuse. Okay, so that's the fuse. Nothing here looks crazy. 120. I want to pull it over here to these batteries. Just make sure I don't see anything here. 124. That doesn't look bad. I am going to slide it up underneath there and just kind of get a view of some of these. $110. See if I can get something back there. There we go. That's what I wanted to see. 110 over there also. And the most hot we see down there is 110. And I'm going to reach my hand over to this here. Just put my hand on it. See if those are warm to the touch. Barely. No. All right, so right now I have the charger running. Just wanted to check. It's in bypass mode, and it shows it's charging. And I want to watch that voltage, that temperature there, and see if it has any effect on it at all. Doesn't look like it's affecting it much at all. We'll pull it over and take a look at the full thing. That's not too bad at all. So we're just going to set this here for a few minutes. I don't see anything. Oh, that temperature is actually going down. It does claim it is in bypass and doing charge. Let's see. Let me see if it's actually charging. I'll be right back. Well, here's the good news. The system performed pretty good. We got the changes to the wiring down here. It's still running pretty hot when around that breaker right at 200 amps. And I didn't let it run for long, but it did prove that this can do it as long as the battery voltage doesn't drop. And I have a feeling that if I had another battery, pulling 200 amps is just at the edge of what those batteries are able to do. So that's probably where the voltage drop is coming from. But this performed the way it should have. It handled it really well. The temperature coming from the new wires is fantastic. I am going to slide these booties back on there because it does make me feel better knowing that those are covered up. But it performed well. Nothing out of the ordinary. It did at first puzzled me with a couple of warnings about voltage and batteries and stuff like that, but I didn't realize it was over the 200 amps. I got 200 amp hour batteries, meaning that with two 100 amp hour batteries, I've got 200 amps of max throughput. So when it pulled more than that, those batteries, it's possible one of those batteries was just shutting down. I don't know that for sure because I was watching only one of them. So, and it could just be that it couldn't pull enough and the voltage was dropping also. So either way, that's not unexpected. Everything is running the way it should. I ran one hair dryer and one heat gun and ramped it up just over 3,000 watts and saw it shut down a couple times. And then I turned off some lights and just did it right at 2900, and it seemed to do pretty good. It ran for quite a while. Now it still gets hot around that fuse, and in this case, if it was me, I would just switch to a T-class fuse and a nice blue C T-class fuse and be done with it. That would solve that problem altogether because that's just not rated for that type of amperage. I could probably go with a blue C fuse holder and get away with it. But those A&L fuses, they still run really hot. And and I don't like anything that goes over 150 degrees. It's a personal preference of mine. So I did run right at the edge of these wires here at a little over 160 after it ran at, you know, three kilowatts for, I don't know, 4 or 5 minutes. But the PV's been running in all day. The box is working great. The inverter's working fantastic. The shutoff works really good. The only thing left we have to discover is going to be the recovery. I'm going to be out of town for a few days, so what I'm going to do is I'm going to leave the shed with a light on and just see if it can handle staying on for a week while I'm gone. And then when I get back, we can go and see how everything's gone. It looks like everything is under conditions of just a light and the solar panels. I am going to switch the solar panels to just have 2 panels instead of 3. I saw that one warning. I've got it right there at the edge, and I'm not comfortable with that. So we'll go on and get those panels mounted this weekend, but we will switch that to 2 panels and keep that. I think it's going to pull in about the same amount of wattage anyway, because it's 20 amps is not really more than 240 anyhow. So 3 panels is kind of overkill of having 750 watts. So it's really not necessary. Overall, the eco-worthy inverter did its job. It sits at about 35 watts of idle power consumption, but it has an auto shutdown for under 15 watts and another one for under 20 or under 30. I don't remember which. Either way, they work great. The only thing they don't, they basically just sit, you can see it sensing the line, and when something's there, it comes back on. So for example, if I turn off all the lights right now, you will see I have this set to shut down, and you can see it just shut down. And you can see all the lights are off and everything's gone. So there is nothing powered now, and this is pulling no power whatsoever. The fans are still kind of running a little bit in order to cool down the unit, because it's still a little bit warm from my testing. But this shuts down and then ran all night long on less than 1% of one battery, because I forgot to turn the second battery on accident. It turned out to be a happy accident, but then when you go to turn something on, like I still have this plugged in, so when I flip this on, you'll see it doesn't come on right away, but then that senses it and it does come on, and then this lights right back up. But the nice thing about it is you can turn this off if you want. You can control it manually, but when you turn off a device, it automatically goes away, and then you'll see it do that again, and it'll shut right back down. So for charging equipment and garage equipment and lawnmowers and batteries for, you know, electrical devices, or if you were even in a lawn crew and you had a bunch of electrical stuff in your trailer and wanted to use this to charge all of them, it's a fantastic option, because a solar panel on the roof and this with a couple of batteries, and you could have the entire electrical system running and keep you out all day. So other than that, the price is right, and there's a link down below if you're interested to save some money on it. Get one of these. I'll also have a link on Amazon for these. I'll have a link for that. I'll have a link for that. There's an entire part list down there of everything here, and it includes the PV panel, which we did not use for this setup because it's a 12-volt system. We can't use more than 240 watts of power anyway, so I didn't bother hooking this up. So technically, we are $100 and something under the budget that's there, but I do have an extra battery that I didn't plan on, so that puts us right back at about $20 under budget, over budget as opposed to under. So either way, the simple thing is everything's working the way it should. The next one in this series, we will test some of the off-on stuff, but that's going to be a few weeks before I get to that. And then we are going to redo the solar shed again with a 48-volt system. You'll notice there's a box sitting right there, and if you can tell what inverter it is, then you'll know what we're going to redo it with. But it will be 48 volts. It's going to be a fun ride. I've got 2 different 48-volt ones I want to build for you and show you how they work and everything. They're going to be fantastic. But the eco-worthy 300-watt, 100-amp-hour charger is really good. And I'm just going to plug this back in, and that will in turn switch this into bypass mode, and it will go into a charge mode. So it just switched to bypass and automatically started charging. And you heard the click, and that's it. And so if I was in an RV park, or if I was at home and I had a lawn crew or something like that where I wanted to charge it, I just plug this in for the night and go to bed. It'd charge up all the batteries. In this case, the solar would do it for us. We don't use enough here in the solar shed. We can do all of our laundry, we can have all the lights, I can have all the equipment, everything out here. I haven't had any need for it. It would be interesting to see if I could insulate this enough to actually put an air conditioner in here and see if I can get that to work. Maybe on the 48 volt one, we'll try that. That's going to be a ways down the road though. So other than that, I think this is it for this video. I don't want to be too much over another hour. I know it's been, they've been 2 really long videos, but they've been very, very full of information, and I think that's the way they need to be. So if you have any suggestions, questions, or any other type of feedback, please let me know. I'll be glad to answer any questions. Just put them in the comments below. And make sure you sign up for the email list. There's a link in the bottom down below to sign up for the email list. I send out offers sometimes, I send out coupons, I send out all kinds of stuff in that. And sometimes I send out special things for special video releases for people that only subscribe to the email list yet. So thanks for watching. We'll see you on the next video. Let's talk about what we're going to do this time around, because this time we are talking about installing the solar panels on the shed. So I want to take you through my thought pattern here. The panels mount behind this vertically, right down here. So what I'm thinking about doing is running some kind of wood all the way around the top of the solar shed on the inside here. Now, the only thing I've got to consider is around in this area, this is not a whole lot of room to work with. So I'll have to figure something out there. And I'm not going to be able to change this much, but I might be able to disconnect it and slide it down and work around it somehow, or even just break the wood on each side and have it come up to this side and have it come up to this side and just end and leave that piece undone. But then it could go all the way back down to this end. So it needs to go all the way around the top so that we can handle the outside. We had a ton of rain here a little while ago, so the sun just came back out. So let me just take you around this is about where that wood would go that we talked about on the inside of the shed here. So I'm thinking if I put a brace or maybe a piece of wood out here also, that some of these can mount based on these clips here. Now, I do have one problem I have to deal with. When I put the additional panels, first set of panels up, I only had enough clips to mount the top and to put 2 clips on the ones on the bottom. The bottom of these don't actually have clips on them. And so I didn't have any extras to put on these panels on here at the end. So you'll notice here, these are black clips. So I think what I'm going to do is have to take this one and the third one on the far side of the shed and move them back here so that these 2 panels are mounted at the same place. Now, the question becomes, is if I put a big enough piece of wood out here for this, can I make these fold out based on hinges? And I don't really know the answer to that yet. If I would be able to do it to get them to kind of sit like they do like this. It does generate between 1 and 1.5 extra kilowatt hours of energy every day with them being tilted like this here. So it's a benefit. It's not huge. It's not like the panels that are mounted up here where we get tons and tons of power. So these down here get a lot less power. So I'm not sure there's anything I can really do about that. So what I'm going to do is see, and I have to worry about this section here where I have these glands already mounted that were behind that solar panel. But I think I still have enough room up here for a 2x4. Maybe I'll get a tape measure and measure it. Either way, you see the challenge when we get there. You can see where the screw holes are here. So I think out here, the same as I had in there where those glands were, it just dawned on me what I need to do. This lines up with the screw holes, meaning this is where that mount would be for that support that's in there. And then we will have to go around that piece of wood that's in there. That will allow us to get some tilt on these panels and work with that. So As you can hear, the neighbor's dog is fearlessly coming after me. Let's see if I can catch him. My viewers have heard you many times. You should say hello. Have a good day, Red. Just a little trip to Home Depot. And a little bit of traffic for a Friday night at 7 o'clock. Now, the idea is to come here and figure out what kind of wood we need to go around the inside of that. I'm a little worried that the weight of the panels is too much to be supported by the aluminum frame of the shed, and that I might just mount them back the way they were, considering the savings was not that dramatic. Now, I still need something to hold them on across the top, but the idea of putting them on hinges, once I put the wood around the top and get it all screwed on, then I think what I can do is just attach them for now, and then possibly look at doing something extra later for hinging some of them, and just to try it out and see how much of an impact I can make. Maybe do some of the, like the two panels on the back, or the panels on the sides, or I don't know, something like that. None of them have good exposure throughout the day with the buildings in the way is the problem. The ones on the south side, the two panels on the back of the shed, which are on the south side, they have a good exposure during the winter. So I don't know how much, though. I don't remember paying that close attention last December, January, of how much exposure there was. I know there was more, because I remember thinking how dramatically the sun moved across. Being here in Central Florida, it moved quite a bit further north in the morning, and so that could impact what I think about it. And maybe I'll just wait until that time of the year comes around. The nice thing about the weather here is that it's actually nicer in December and January than it is the rest of the year, as we don't really have any of the heat that you would have, or the cold that you have everywhere else. So either way, that's the idea. We'll see inside at the wood selection. You know, one thing I forgot that I do need is a tube of good weather protectant clear caulk in order to make sure that I don't want to use white. I would like clear. Here we go. Silicone advanced, 100% waterproof. That's what we want right there. This will help us secure the screws that we put in those sides and just kind of overall keep it from leaking. I did all that work to get it to stop leaking. I don't want to do any damage on it. So now it's quite slow here because it rained like heck earlier. So I'll take you down there to the wood and we'll see what we have as an option there. See what we can do.
Come back down this road.
All right. So really, we've got a few choices here. I can go with something like this with a 1x4. I don't like doing that because they're not quite as wide, but they do accomplish the goal of I think $6, $7 a board. And we only need a few, so that's not too much of a big deal. And they do have the larger ones where we could get the 10-footers, $12 a board. It's crazy. Or we could just go with a straight 2x4. Let's go over there and take a look at that too, and just see what that's going to run. This wood is a little bit well priced for what I want to use it for. So let's try the 2x4 out. All right, so here, it's nice to use some of the weather treated stuff that comes from the fence. The price is really good, but 2x4s are always a good option. They do have the 8-footers. We do need a couple of 10-footers for the outside. So that would take care of that. I'm wondering if I could get, let's just look around a little bit and see what options we have here. Some runner boards, and those are too small for sure. All their pressure treated stuff, and these are big 2x6s, 2x8s, 2x10s, 2x12s. And they are getting a little smaller here, but not really going to meet our needs. So let's go back over here. Look more like the fencing wood was probably the best price, but I'm not sure it's the best option. Not really what we need. What we need is something, well, those might work. Those are good and thick. They would work on the inside and the out. I don't think they have them long enough that I'll need 10-footers. So now I do have to split that though. I didn't even think about that. So I have to split that on the inside and the out. So I could do that with basically I could probably do that and split it because I've got that the beam where the wires go in. Those things, that's what we need to do. So maybe those are the best thing. These are pine dog-eared pickets. Doesn't look like they're treated in any way. They do look a little treated though. It's hard to say if they're just dusty and dirty or if they're actually treated. The other option is to go with premium whitewood, just some studs, and put a 2x4 stud on the inside and outside. That definitely would have the strength that we're looking for, but I'm not sure that it's going to give us any better of a solution. The problem with that is they're so thick. And I don't know that I need the thickness. Now, it would allow me to put some good screws through them, though. So that's an interesting idea. So I can attach them well with the screws. Let's go down here and see what else we have as an option, if anything. Got some fencing posts, but there's not slats or anything. There's some wood back here buried behind this delivery. I don't know if this is going to help us any at all. No, these are just some more, some of the premium pine 2x6s, 2x8s, 2x10s, that kind of stuff. So that won't do us any good. All right, so that is really our option. Now the other option we have, let's just walk around there and just to be sure we checked everything. So let's see if there's anything here. Oh, this we already checked. The prices on those were ridiculous. So that won't work either. It ain't going to gain us anything except a higher price. And we really don't know how long that shed's going to be there or how long we're going to live there. So this is kind of just a fun project. But it does need to withstand some winds and stuff. 260 foot, a long foot. Yeah, I don't think we'll be doing that. It is popular though. Not just regular wood. That's some nice wood. All right. So I guess the fence posts are the answers. See if I can find us a cart. Got a few of them. All right. So now let's determine how many pieces we need. The back of the shed is 8 foot. The sides are 10. The sides are definitely going to need 2 pieces each. So we'll take 2 for the front, or 2 for the east, 2 for the west. Oh, what we got to do inside and outside, don't we? Huh. Yeah, we certainly do. And we have to have something to attach them to. So 2 more. And 2 more. And then I'm going to assume after I cut these, that is really, really dirty. I'm going to assume after I cut these, there's going to be plenty of length left. Yeah, the question is, do I want to do that? Those panels with 30 and 60, 60, 72, 6 feet. These are 6 feet. Yeah, I don't know if that's going to be long enough is the problem. If not, I'll have to find a way to use some scraps to piece them together. So 2 for the south side. And so 2 for the south side, inside and outside for the south side, and 4 for the west, and 4 for the east. And we'll just screw the outside piece to the inside piece, and then use this as a mount. And then that can mount, then the screw for the solar panel can go all the way through the inside and the outside and the shed. Okay. This always seems to happen when you come to Home Depot. As you walk into the store, you realize, oh, I forgot this, and oh, I need that. So now we're going to look at some fasteners or some screws to put those boards together. Now, it goes through that aluminum pretty easy, and I like these ones with the big heads on them. But I need them long enough to go through both sides of the wood. And I don't want the self-setters, self-set. Those are too long. 1 inch. I don't think those are long enough with the shed. Adding to it. We need to go 1 inch, 1 5/8. That could do it. I don't think it needs to be 2 inches. I think 1 5/8 should be enough. So what I'm thinking is we've got 2 pieces of wood and a third piece, which is the equivalent of the shed. So if we do it that way, I don't think it's going to be long enough. So I think that shed, the ridge on the shed, is going to push this out and take the space of another piece of wood. So these need to be thick enough to go. I'm thinking we go to 2 inches. And that would give us enough to do all 3. If they stick out a tiny bit on the back side, I think I'm okay with that. I would rather have that than them not hold. I really don't think anything else. Look around a little bit more. I don't think I don't think I want to do anything else. I think these will work just fine for me. So, all right. So we're going to try the 2-inchers. If they're too long, I can hear 100 people telling me I told you so. Back to the reckless driving of the car. All right, we're loaded up, ready to go home. Here we go. That was a pretty eventless trip. Easy pickup of supplies. Now we head back home. It's still Friday night. I mean, it's not going to get done tonight, but especially with the way the mosquitoes have been lately, woo, they are killer with all this rain and this heat. They get hungry and they just want to take you all out. So the idea here again is to go around the top with wood. Now we have kind of a conflict here. We have to make up our mind whether we're going to go with hinged or whether we're going to go with attached. And I think I'm just going to go with attached because I know I'll be able to get that done. I don't know if you're aware of it, but I actually am heading out of town Monday morning to Atlanta for Dragon Con. And I already have Solar Video 2 posted for the members. So if you're a member, you have probably already seen it before everyone else, because I always try to release everything as early as possible for the members to watch. All levels of membership get it. I do post an occasional picture and things like that for the second tier, and then the third tier gets a short here and there that basically explains what's going on. Usually things about behind the scenes and that kind of stuff. And then, of course, those members and all of my members are helping to some degree with paying for some of the stuff that I build. And thank you for that. That it does help out. Believe it or not, there's still a lot of little things like this that cost money. The wood, the screws, that kind of stuff. And so it does help pay for some of that stuff. And I appreciate all of my members. You guys are wonderful. I don't know how many of you are familiar with our Sunday solar live streams. We do a live stream, or I do a live stream with the help of a camera crew on Sunday every week. They come in and set up quite a quite a hoop to do for me. If you're in the Merritt Island area and looking for someone to help you with live streams or recording and all of that kind of stuff, let me know. I'll be glad to pass along their name. They're fantastic. They're from a local filming school around here, and they're really good. They're very helpful, and they're always willing to stay late. As most of you know, my live streams have a tendency to last for hours once I get started. My live streams are 100% open to questions of any sort, anytime. I look at them as a way to communicate and talk with you guys, and they're more your time than they are mine. So please feel free to show up to any one of them, especially if you're building a system or you're doing something like that. And on that note, if you are looking for equipment, all of the equipment from the list here will be included in the QR code that you see on the screen throughout this video. And there's also, if you're not on the TV watching this and you're just watching it on YouTube, in the comments below, I include a link to a full parts list. I also include a couple of extra sections, one for upgrades that are probably good ideas for things that either could be bigger, like batteries. If you wanted a bigger battery bank, I'll make suggestions on that. And then, of course, there's other things like the fuse in the first video in the series. And if you've missed that, I'll include a link to that here so that you can follow it. And there's also a link to the second one down below, to the second video in the series. But if you're interested in panels or anything like that, there's links below. I cover all the different products, and I include, in addition to the extra products, I also include some of the tools that I use. So if I used a torque wrench or a torque screwdriver, or if I used a cable clamper or things like that, I'll try to always include those. And if you notice that I missed something, please let me know. I'll be glad to include those. Anyway, we will be home shortly. So today we're going to work on taking this wood down here and getting it mounted up there so we can put these panels up. Now, before I do that though, I'm going to have to disconnect some of these panels, which works out because this one, it has the different brackets on it and it needs to be moved anyway. We will be using 100% solar power from the solar shed today for all equipment, unless I specifically say we aren't. We're going to be using the saw from over here and everything else. So let's start by getting this panel out of here. I'll lean that a little bit better. All right. Solar gods are with me today. I was able to take all of those off without a releaser. Don't work that often that way. Usually it's exactly the opposite. Even with a MC4 disconnector, you end up coming up short of being able to get it to work right. We're going to make sure that this saw will start under the power of that inverter. Seems to be just fine. Then we're going to measure this wood and make sure we bought the right stuff. So I'm thinking we basically go from end to end and we just cut off what is not needed for that. Now we need a matching one for inside also. So let's make sure that we get this right. We can mount that across here where those holes are. And as you can see, those holes are up here in that zone right there. So we want to make sure that these go in a similar area there. Later I'll get some help to hold these up while I'll put a screw in a couple of places from the back side to hold these up for the back piece to also clip in. So I need an inside matching piece. So we're going to say this is north outside facing. And then we're going to take a second one. And this will be the matching one for the inside. And this is north. That ain't north. What am I talking about? It is west. So this is west inside facing. And we're going to say, yeah, I need this to be back to it. So this is going to be backed to this way. And that means I need to cut right here to match on the inside. And that will give us the matching front piece. And what we will do is say, okay, this goes on the outside, this goes on the inside. That makes this the front. And I'm just going to put an arrow towards the front on both of these. A lot of the times when you cut wood like this, or at least when I cut wood like this, I end up with a bunch of wood all cut up, and then I don't remember where it all went. So I don't want that this time. All right, so that's that. I'll set those there. And then let's repeat for the back side. Up at this height, down to right about here. And this is going to be west, outside, back. And I'm going to put an arrow pointing that way. I'm pretty sure I put west outside front on that one, and I did with an arrow. West outside back with an arrow pointing forward. All right, so then we cut this one. And then we need the matching set. And this is going to be west, inside, back, that pointing forward. Yeah, that's right. And then we just take this piece and put it on top of this piece and just cut it. Not really measuring anything here. We are sizing this directly to the size of the shed so that everything fits, because we don't know where the measurements for those glands went. Those glands went where they were most appropriately fit, or where I drew an imaginary line and popped them through the wall. In hindsight, I probably could have got them closer to the solar over there, but here it was right in the middle. I knew I could feed the top down to it, and this side could feed into it. At that point, there were only two panels, and this front piece was open, and behind it is all the solar equipment was mounted. So that's why it's done that way. All right, so that's that one, and that's that one. Now, let's switch to the other side. can do the same thing. We use these for setting equipment on at the coffee shows. They're not great for excessive amounts of weight for long periods of time, but they are good for moving things around quickly and getting them done what you need to get done. So now we start on this side here, and we do the same thing. We just see if we can disconnect these panels. Wow, must be my day. Well, I spoke too soon. Now I need a clip remover. All right, you know what? This has an extension on it. And the extension comes right off, so I'm just going to use it. And we're back in luck. And I'll just put this over here in case I do need it at some point. All right. Now let's look at, same thing's true over here. You can see the screw holes where the panels were set up. These over here drop. So what we'll need to do is we'll need to seal these holes because we're going to put new ones in up here. And we want all of those sealed. Okay, let's get to cutting. The gland on this side doesn't exist in the way. So all I'm going to do is cut off this dogtail on the end so that the wood can just line up with another piece of wood. And then we'll just trim off the extra. So if that goes like that, which is good, that'll leave that end just right here on the edge of this. And we'll take the second one and we'll just line it up with this one. I know you can't see that. We'll take the second one. I'm just going to seam those together over there. Take out this staple. Seam those together on this seam here, which is the important thing. Overlap this one enough to where I can get a good grip on it, but yet it's not sticking off the edge of the shed. So I can get a good grip into this without it sticking off the edge of the shed here. And then we'll cut this one to match. We're going to basically make sure that this doesn't stick out over here any, and it doesn't. It's perfect, but I still have access to each of these grooves to screw it down. All right, that is from the outside. Now let's talk about what we're going to do on the inside over here. So let's just get the two pieces of wood that we need. We're going to do the same thing. level out one of these ends. Matter of fact, I'm going to level out both of these ends since I have a little extra wood on both of them. Might as well take the good wood. Then, that was probably not a good idea, because now this may not be long enough. Actually, you won't believe this, it's exactly the right length. All right, so we leave that one without it cutting it. It'll have the dog ears on the end, but it'll be at the front. I'm not going to worry about it. And then the other piece, which is that piece there, that's for the back. Do the same thing here. Whoa. And let's cut this end off. All right. So now we have two sandwich pieces. We know that piece goes in the back corner. So we're going to put this at the front, and we're going to call this east, outside. And it goes this way. And this one is going to be east, inside. And that arrow is going to point that way. And I put 3 letters on the other side. Oh yeah, I need the front and the back labeled. Okay, so this is the back, and this is east, inside, front, and this is east, outside, front. All right, that takes care of that. Now, for the back piece, this is where things get tricky. Much more tricky than those panels there. I don't think I have enough wood for this one is my problem. I was expecting those scraps to be longer. So let me move you where you can see what I'm doing. All right. So let's just see what we have for wood over here. And as you can see, that is short. I need a piece to cover that in too. So what I'm thinking might be the right way to do this is I got to make another trip to Home Depot to get another one of these for the inside. But I'm thinking either way, it's not long enough to cover the whole thing. And I don't want the seam here on this piece. What I'm thinking is if I do it this way and cut it off here, then I could just mount that other piece over there and leave the gap here in the middle. And to be honest with you, it's not going to matter, is it? So let's just take from here to here, and this will covers the seam for both of those. Let's take that all the way to here so I get this. And then that leaves me on this end plenty of room to do that. And there'll be a gap in the middle, but it won't be a problem gap. I don't know if you can see me here. I'm going to go over there first before I cut, make sure. All right, so we're going to cut this one at this length. And then we're going to take, and we need both pieces of this, because what we're going to do is put the long piece on this side and the short piece on that side and leave a little gap behind this panel right here. So like right here, between the ending of this one and the beginning of that one, there'll be a gap this big. If it bothers me, I'll either get some scraps or I'll go buy another board and fill it in. I honestly don't think I'll even care. All right. So that's that. Now let's cut this one to match exactly the same size. And if that matches, this should match. And it does. And we just want to cut that here. All right. So one of these is the inside. One of these is the outside. I'm just going to take this one and designate it the inside and put it over here. I'm not even going to bother labeling these. They only fit one way. Put this one over here. And then these, back, front, outside, outside, inside, inside. Let's take these, put them here. And that means the front goes here. And the back goes here. And then that seam here has nothing to do with the clamps of where the panels will go. Everything has solid wood to mount on. And we're going to sandwich the wood on both sides. This gives us two pieces of wood to soak through, and it gives me the support of the entire shed along the wall, not just one piece of it. If I still see there's some integrity issues, or if I see there's some integrity issues, then what I can do is I can take those inside beams and put runners across to support them or reinforce them somehow. At this point, I haven't seen that. It worked with just basically back scraps holding those panels on. Something like this was just in the back where the screws went in. And so this was kind of like that. This is going to extend that and make it even stronger. So I don't see that we'll have a problem there. And that should get us ready for the initial piece, which I'm going to put all of these up all the way around the outside with some help and just get some screws from the inside in them to hold them up. And then I will take the inside and screw all the way through to the outside, mashing them together all the way around. And I can do that by myself. And then I can get on to remounting the panels. Then we can switch these two out for the ones with the brackets. All right, today is a tough day. We got this one up, but it started raining just as we put the couple of support screws in. So it has 3 support screws from the inside in these ribs, mounting them here. I'm going to take you in there and show you that, and then we're going to mount the backing boards to them also. I'm going to try to open this up. We're going to deal with this rain as best as we can today, because this has to get done because I got to go out of town. All right, so I'm going to set this up here so you can see it. This is the screw that's holding that board on, and there's 3 of them. There's one there, and there's one down right around there. Is hopefully I can put 2 of these in. So this is the one that goes in front, west in front, and the arrow's pointing that way. So that means it needs to go up behind this wiring here, and it should go about like this. And it's a perfect fit. Now, what I don't know is exactly how far from the top that is outside. So what I'm going to do is run out there real quick with a tape measure and figure it out. All right, so out here, you can see, I can tell, I'm going to try to do this without getting in the way of that sun there, that we are about 4 inches from the top. Whoops, sorry, you can't see that. So we're about 4 inches from the top. That includes that aluminum stud that these are screwed into. That angle is really bad, sorry about that. That includes this aluminum stud that these are screwed into. So that stud is there so that we have good support only 4 inches away. So what I want to do is I want to put that 2x4 or that other board behind this exactly 4 inches down minus that stud so that these line up perfectly. And I just want to measure this at a couple of different places and make sure that we are about the same all the way up and down this train. And it looks like we are pretty close either way. All right, so now we go back inside and see if we can screw those in. So here we are back inside, and we know that this aluminum stud here is where this is attached. And I'm pretty sure you can see that stud in this picture. Yes, you can. So it runs, and I can reach my finger over this and feel that aluminum underneath it. So we know it's 4 inches from that is where the one on the outside is posted. So what I'm going to try to do here is just mark that somehow with this Sharpie. That's a good thing. Just mark it here and down at this end. It doesn't have to be precise because we're not going to be putting, there isn't that much, we have plenty of room outside for the screws to go in. So even if it misses by a little bit, as long as you're not going to be able to see it from the inside of the outside. So let's take this now and slide this up to where it is at 4 inches, just like this, level all the way across. Right about there. And let's just try to put one in. Let's go through this one. That worked pretty well. I felt it grip really good on that back side. So we're going to do the same over here. Bring that up to 4 inches. I want one right here at this end. And that tightened that up really good too. All right. So now that we know that works, I'm going to go out to the outside and let's put a few more screws in out there coming back this way, because if it's going to be if they're too long, I don't want them sticking. Oh, and they're not. You can see there, they did not stick out. So that said, I'm going to go ahead and then just put a few more in from in here so that that's held really well. I don't want to take any chances of it coming loose. It's the best support we have is holding into this thing. So we're just going to go across one high and then one low all the way across like this. And then one more this far in down here. Oh, actually 2 more. We'll go low here. And then we'll go high on this one here. Yeah, we should be on there really good. And go back out and confirm out here. These should not move, and they have absolutely no movement in them. They're really good held on there now. And they've got the support of that aluminum frame all the way across now. So this whole wall is one giant support frame now, as opposed to it just being attached in little pieces. Wonderful. So now let's redo this again. Only let's do it with the back one. My way through here. And we want this pointing towards the front. And then we want to do 4 inches approximately from the top. Right in that area. And repeat down here. Now, the old screw holes, the old screw holes are right here. And I can see the wood on the other side of them. So that means we do have that covered, as long as this covers that entire, and it does, that entire set of screw holes there also. So now, let's do this. Let's get a couple of screws, because we need 2 to get this started. And we'll need a few more after that to finish it up. But let's start with the first 2, one on one end and one on the other, to give it all support to hold it in place. All right. Put that there. Now I'm just going to go dead center here. And I'm going to pull that up and get a second one in at this end. I'm going to go all the way to the end this time. Wow. That left hand is just not as skilled at screwing as the other hand. It pulled that trigger and shot that screw in. All right, we're going to go a little high on this one. And that's better. And then a little low on this one. And even though it rained a few minutes ago, the sun is back out, and it is getting hot in here. I'm going to have to do this in waves today and just take a break after every section. So, high again. Low again. High again. And a little low, but more middle. There we go. That side is done. See you after I cool off. Here's what I have to do. I've got to determine the difference in this bracket and this bracket, and mounting that last form back here. Because these look great, and they'll fit those solar panels perfectly. As a matter of fact, let's test one of those solar panels and make sure they fit perfectly before we go any further with any of the other ones. So I've got to move these over here anyway. So let's just take these off. There we go. And let's take this one over here. And let's just see where it falls. Oh, look at that. It's perfect. So that will mount right like that. And it's perfectly in the right spot. The nice thing is now it sticks out far enough to be over the lip of this also, which was an issue. It's a little tiny bit more straight up and down, but that's not going to be a big deal. with the angles that they're at anyway. So that is great. I'm going to find a screwdriver, and actually I'm just going to lean this down this way for now, and then let's try measuring the other way here. I'm going to get this other one down and out, and let's move it over there also. Just unplug this, and let's just pick this panel up and take it over here. I'm going to try it at this other end. I don't know if you can see me from there. It fits down here perfectly too. So we are all golden on this side. Now let's take a panel with the black brackets, which should be a few inches lower than the ones with the silver brackets. They do mount a little lower. And so that, we'll put that down about right there. So the good news is this will get it up off the shed here too. And I may need to put something down here on the bottom to build it out a little bit, because that might have it may lean a little this way, like this, an exaggerated view of it. And I really wouldn't want that. So I may end up having to put something out here to hold it up. But for now, we know where it needs to be based on this. So let's measure and get that up there how it's supposed to be, or where it's supposed to be. And that hole was, oh, I see, right there. Okay, so I am going to mark these screws where these screw holes need to be, and then we can measure down from there. I want to measure it at both sides here. Measure twice, do the work 3 times, or do it once. Set this panel over here now and find us a tape measure and put some marks on there. All right, so we're going to put those screws right smack dab in the middle of this. They were here and here. So if I put it in the middle, do the same measurement as I did before, it is going to be 5 3/4 inch down. So what I'm going to do is mark this now. And mark this one. And then I'm going to come over here and do the same on this side. As you remember, we have this one's in separated wood here. So I'm going to pull this back 5 3/4 to this area right here, and 5 3/4. This was the important one because this is the one where all the screws go in. Right there. All right. Now we're ready to mount these. And then we'll put the screws in the backside. See you in a few. All right, same thing in here. We're going to go in 5 3/4 of the way down. I'm going to put a screw in each side just to hold it. Put one here. And that puts the center of it about right here. That come through? Okay. Now at the far end, I'm going to do it again. Okay, now there's a short one for the other side. All right, the one on your right first. And the one on your left. All right. Thank you. Now we're going to take these two and attach them on the inside using the same long screws we used before. It's the same thickness, it's just in a different location. So here comes the rain. This time I'm inside though, so I'm okay. So here's what we're going to do. We're going to 5 3/4 is right about here. So I'm going to put one in right smack dab in the middle here. And then I'm going to remeasure across it and balance it out some if it's needed. Underneath those wires, that's way too much. Oh, yes, it is. It's very high. Let's see about this end. All right, so this one is a little bit high. I think I'm going to take it off and put it back in a little higher because it needs to be 5 3/4, and that's what you get for estimating when you're doing things like this. It should be way up here. All right, no problem. I'm out of the rain. I'm okay. I'm going to take this out. And I'm going to slide it up. And I'm going to tighten it back down. Now, we're going to remeasure that again and put 2 more support screws in it. 5 3/4. Turn this just a little bit. Get it as close as we can anyway. 5 1/2. 5 1/2. Close enough. So I'm going to put one here. And I'm going to put another one over here. And that should take care of that. Now, let's look at the other side of this. So let's see if we can measure this out again. 5 and I'm going to go 5 1/2. I'm going to go 5 1/2 to somewhat make it level with that one. It shouldn't make a difference outside. And I don't want it to be completely off when you walk in from the shed and look back at it. I grab a couple of extra screws here so we have enough to work with. We got 1, 2, 3, 4, 5, 6 or 7 ridges here. So let's just plan on one on each. And let's take this and see if we can put one there. One there for a good start. And then we're going to start going across here. That's up. That's down. up. That's down. This one's going to go on the upper side. It's not going to be up. There we go. Now, we're going to go outside. I hear the rain has slowed again. And see if this is going to work. It's nice and wet and messy out here. When it starts raining, I start running. Let's see if I can get this set back where you can see. This is the one that goes to the solar shed system that we've actually built. So I want to get it done first, because if the RV doesn't have a little bit of power, it's fine. It's got some backup plans. This is completely off grid. So it needs to be set up in order to power everything in the solar shed, including the wash machines, which we're going to need to do some laundry before we leave town. That is one. And this is two. Now, the screws I used on the inside, I'm going to show you this. The screws I used on the inside were longer than the ones I used on the other side. I didn't have any more of those short ones. And these stuck out. Now, the problem I have is this is where the panel is. There's plenty of room in that side of that panel container. And so are both of these. Won't be a problem. But, oh, actually, you know what? Neither will this one. It'll be on the inside there too. Well, we just need to try it. We'll see. They screw in over here, so if those clamps are on the right of this, then we won't have an issue. All right, let me just try it. Otherwise, we're going to have to find either a grinding wheel or some good cutters and cut that completely off at that short side, because that screw is buried now in that wood on the inside, underneath the wood on the inside. So let's start by doing this one over here. We've got two wires we need to connect. One has to connect here. So that's an easy one to get hooked up. And I picked the perfect day to do this because there's giant clouds above me, making it cooler, but also there wouldn't have been any solar anyway. So as it turns out, it wasn't the end of the world anyhow. All right, so let's pull that in a little bit, and that fell in place. I felt it fall in place. I think that's just fine. It might work just fine. So now I need a screwdriver, and I can't reach it without putting this back down on the ground because the wind is picking up again. So let's do this. And I don't want to use these screws. These self-setting screws, they're great. These self-setting screws are great when you're going into metal, and a lot of metal, aluminum studs and stuff. But when you're going into wood, you're better off drilling a hole in that clamp on the side over there and then putting a real screw in, because it drills out this wood and then they don't hold. All right. So this is the solar panels on the west part of the roof. So we are going to flip that on, as you can see. $92 volts. Then on the roof, which is this one here, it is 97 volts. All right. The other one, which is this one here, which is the east side, it is at 2 volts, which is because we still haven't hooked the panels up. So I'm going to turn these two back on. Those will go back into the RV. And then we're going to take a look at the Victron app for the solar shed versions that come directly into this Victron right here, which is, all right. We're going to do a little test, make sure that all 3 of these strings are lit up. We know the first 2 we already did, so we're just going to test this third one, which is this east side. And I'll hang this, I'll set this right here so we can see it. And let's just go through, it's on AC, let's just switch that to DC. There we go. And it is this string here that we're looking at. And we are at 98 volts. That's good. Now, I wanted to go back and retest this one here. It showed some lower voltage earlier today. I just want to see what the voltage is on this one over here, which is also 88 volts, but that's got a draw on it. This one does not. Okay, it's 99 now, and it's 98. That's good. And if I take the draw off of this one, it is 103. It's still a little higher, but it's the one that faces up. I would expect it to be a little higher. I do want to check the polarity on them all. I wasn't paying that close attention. Positive, 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 positive. All right. Those 3 strings are all back on. The string for the solar shed itself is back on. And so we are going to go over to the outside panels and do a walkthrough of them. I'm going to show you how I finished them up. Here's what we got now. The side over here on the east side that faces the river, I've got an extension cord that still runs behind behind here. I got to get that out of there, but I can just pull that through from behind them. Now there is enough room behind them now to actually get back there and pull wires and stuff, which is kind of nice. That I never had before, because this little bit of extra up here at the top really makes a difference in getting them in there. These boards are attached on both sides and sandwich the shed and provide the full support of the shed now all the way across. I did overlap these here simply because they needed to be closer together in order for the existing wires that ran from one to another and then back to that gland that was there. This one over here had a long run to get to the gland that's right about there. So I did push them a little closer together to allow it to reach that gland, but they all went in straight for the studs. And then we have the back 2 panels, which we still have the connector up here to connect to that third one on the roof over there. But we don't have it hooked up yet. We may even try doing something where we put 4 on the roof and on their own charger and see what we can get out of that. That might even be better. Here, they are overlapped a little bit in the back, but that is just so that they fit the corners here really nice and stay on the wood. And that is true on both sides. They fit the corners about the same and stay on the wood. So, and this side is also attached very well, nice and sturdy now with, as you can see, a couple of screws down at the bottom that just get in the way of the panel coming out. The bottom's not really the problem where it comes out, but I like it sitting on that runner board there that is attached to the shed foundation. That one's actually the shed foundation. These on the side have runner boards attached to them where the panels sit on to support their weight. These last panels were added, these 2 front panels. So you'll see there's just a runner board extension there that allows all the cables for going in and out of the shed to still exist. Although today, with the solar shed truly not just providing power to the RV, oh, I missed one here. Then I missed this whole side, the second set of screws. Now this side is just is truly independent, then it probably doesn't need all those glands going in and out over there. Now we're going to go through here and see what we can do about sealing this up and take care of that. Other than that, though, the panels are on. The roof panels, as you can see here, they just need some caulk to screw them, to hold them in. They are basically set up in there, and I'm having a hard time seeing my phone when I raise it up like this. But you can see those panels are set there. They just sit up on the top, and then they screw into the frame, the same aluminum frame that we measured from under here when we were putting these screw directly into. So here they're screwed directly into the frame. Up there they're just screwed into a light mount on the inside. Nothing major. Hopefully that's good enough. Same thing on this side. And we did go back in a previous video and seal all the underneath this, took all this off and sealed all the holes in this. So now we're going to take some caulk and we're going to seal all of these remaining holes here and get rid of all of that leaking and everything there. I don't know if anything from behind here, behind this board where these screws go through, will actually leak on the inside. I do know that this is making it into the shed from here. So what I might do is pop this panel off before I'm done here and just run a bead of caulk down the edge of this. Keep that water from getting inside. That should be enough to stop it. But I don't think I can do it today because it's still wet. So I may have to wait until I get back to do that. In that note, I'm going to leave these undone. And we will do that when I get back and seal that up so that that can not leak. Other than that, I think we're done. Everything's working again. Everything's attached. To sum it up, we basically sandwiched on the shed 2 pieces of wood, screwed the panels into the wood, attached them to a mounting rail at the bottom. We run 3 parallel on this side. That cable runs to that extra panel. That's going to be part of that backward series for this when we finish the solar shed. And same thing's true here and over here. The 4 panels just sit on the roof and are bolted into the frame. So it's pretty straightforward. In summary, I feel much better about it. Everything should be working just fine.